Okay, so this is a question we've been given where we've been asked to calculate the number of moles of oxygen difluoride present in a given sample. What we've been told is that a group of A-level chemists have measured the mass of the sample, and we've been presented with what the mass is. We've also been given the formula of this compound, and we've been asked to give our answer to 2 decimal places. Now, in this particular case, one of the questions which I would invite you to ask is, do we need the periodic table in order to solve this question? And I'll give you a moment to reflect on that. Well, in this case, I guess it depends, would be the answer. And it would really depend on if you know what the relative atomic masses of oxygen and fluorine are from memory, effectively. But long story short, yes, we do need the periodic table to resolve this question. Now, what formula would we be using in this question? Well, what we know is that we've been asked to calculate the number of moles, and the formula is we've got mass equals moles multiplied by molar mass. Mass equals moles we've already got that in moles, so we could just write, we put in moles multiplied by molar mass, right? Now, and then that would be in, and then if we look carefully, we've got grams here. So for the molar mass in this case, we're looking at it in grams per mole. So grams per mole to the -1, and then that would be in grams. And what have we been asked to look for? We've been asked to figure out what the moles are, right? So in a case like this, what we would need to do is rearrange this equation as to reflect what we actually need, which in this case is the number of moles, right? So in order to put the moles on one side of the equation and make it the subject of the equation, what I'm going to do is divide both sides of the equation by the molar mass, right? So in effect, what I'm going to do is mass divided by the molar mass. And we're going to divide this side of the equation as well by molar mass. And of course, when we cancel this out, we get that is going to be equal to 1 effectively. So, but what we get ultimately is that the moles is equal to the mass divided by the molar mass. And from this point, I would say it's quite straightforward. What we need to do is plug in the relevant numbers. And what we know is that here we've got the mass is equal to, it's given in the question, the mass is equal to 18.9 grams. And the molar mass is not given directly in the question. This is one of the components we need to work out. And so that is going to be, actually, there's going to be the molar mass of OF2, right? So, and that is going to be equal to the sum of effectively the atoms of element plus relative atomic mass of element. Now in this case, as you can quite clearly see, we've got two elements. We've got oxygen and we've got the fluorine. So how are we going to work out that? So if we refer here, what I've got is I've got a periodic table here. We've got the relative atomic mass here. So for oxygen it's 16, and for fluorine we can see it's 19. And so if we apply this formula, you've got atoms of element. So let's do the oxygen first. So the atoms of oxygen in OF2 is going to be 1, right? So 1 multiplied by the relative atomic mass of the element, which in this case is 16. So 1 times 16, right? And just to clarify, okay, that this is relating to the oxygen, and we're going to add this. So we're going to sum this to the atoms of the element. In this case, fluorine is going to be 2, right? Multiplied by. I've just realized this formula is actually, just to clarify, this is not. Yeah. So this should not be a plus. Atoms of element multiplied by. So just to clarify, that was actually meant to be a multiplication symbol. Atoms of element multiplied by relative atomic mass of element, right? Yeah, so 1 multiplied by 16 plus 2 multiplied, yeah, anyway, so 2, and then we multiply that by the relative atomic mass of the element. So in this case is fluorine, right? So that's going to be multiplied by 19, right? So, and then if you get a calculator, we would invite you to have a go at working this out. But the number you should get after that is 54, right? So I'm just going to put the clarification here that this is fluorine, right? So, and then that's going to be equal to 54. So this is going to be the so grams per mole. So this is going to be the molar mass, right? So we've got the mass. We've now effectively worked out the molar mass now as well, right? So molar mass equals 54 grams per mole. And we know from this formula, all we effectively need to do at this stage is divide the mass by the molar mass, and that will give us the moles. So we effectively need to do 18.9 divided by 54, right? So if we do that, so if you do have a go at working that out, what you should get is 0.35. Yeah. Now this is the number, but one of the things you want to be careful at this stage is that, okay, great, you've worked out what the number is, but to give it actual meaning in the context of what's been asked, we do need to assign the units, right? And if you're ever confused about what the units needs to be, just look at the equation, right? In this case, we've got mass in grams divided by the molar mass in grams per mole, grams divided by grams per mole, so -1 is I mean, effectively what you're doing here, to put it in perspective, is you're doing, okay, first of all, just to clarify, that is going to cancel, right? But what you've effectively got left is 1 over the moles to the power of -1, right? Now we know that what a mole to the power of -1 is, it's like 1 over the moles, right? And if you're dividing 1 by this, right, 1 divided by that, you know, we know mathematically that is just going to be equal to moles, right? So I mean, hopefully that does make sense. But we get our units of moles. You know, you can, yeah. Okay, so effectively, to complete this answer, we need to put this on 0.35 moles. So to answer the question, calculate the number of moles of oxygen difluoride. In this case, it's 0.35. And if we just check the requirements specified in the question, we have been asked specifically, if your answer has decimals, give it to 2 decimal places. So we do need to check, did we adhere to that requirement? And as you can see from the answer, yes, we did adhere to that. The answer has been given to 2 decimal places. Yeah, okay.